Hi, Year 12. This is the first in a series of lessons for the topic of integration. In this first lesson, we're going to look at indefinite integrals. So recall, to find an antiderivative, we must reverse the process of differentiation. And that process of finding the antiderivative, it's called integration. So let's find an antiderivative of 6x squared. We want to go back in our minds to think of the function that we differentiated to end up with 6x squared. And we looked at this last topic and we found this rule. We're going to take the power and raise it by 1 and divide by the new power. And I can do some cancelling here. I end up with 2x cubed. 2x cubed is an antiderivative of 6x squared. And this is how it works. Integration and differentiation, they are opposite operations. If I take 6x squared and integrate it, I get 2x cubed. If I take 2x cubed and differentiate it, I get 6x squared. You may also recall that if we have our derivative f dashed of x is equal to 0, we don't actually know what f of x is. It could be any real number. And that's because through the process of differentiation, we've actually lost some of the information. So we would have started off with some constant, like say 7. We differentiated it and got 0, and there's no way to get back to that 7 through integration. And so for that reason, we say an antiderivative of 6x squared is 2x cubed. But if we want to be more formal, then the antiderivative of 6x squared is 2x cubed plus c. And c is called the constant of integration. Now here's the notation that we use. So this here, this is an integral sign. And this means with respect to x. And this is what we say. Integrate 7x squared minus 5x plus 4 with respect to x. And furthermore, this is called an indefinite integral. So let's do this question. Remember the rule? 7x, we're going to raise this by 1, so 3, divided by 3. Take away 5x, that's to the power of 1 currently, so 5x squared divided by 2. And if I integrate 4, I'm going to get 4x. And don't forget your plus c. So here's a couple of examples. Integrate cos x dx. Let's think back in our mind to the function we would have differentiated to get cos x. Now we know it's going to be sin x, but is it positive sin x or negative sin x? It's going to be positive sin x. Think about it. Differentiate sin x, we get cos x. And don't forget your plus c. How about this one? Nice easy one. The derivative of e to the x is e to the x, so the integral of e to the x is e to the x plus c. And what about this one? Now remember, this is x to the negative 1. If I raise that by 1, I get x to the 0 divided by 0. Now we can't do that, remember? This is log base e of x. So it's equal to log base e of x, or ln x, plus c. Now, unlike differentiation, there is no product rule and there's no quotient rule. So we're limited in some of the functions that we can integrate. So for example, if we get a product, we have to expand it out first. That's the only way to do it. So we're going to go 4x squared, take away x cubed, take away 4 plus x. Now make sure you keep your notation because we haven't integrated yet. All we've done is some algebra. Now we're going to go term by term. So this will be 4x cubed over 3, take away x to the power of 4 over 4, take away 4x plus x squared on 2 plus c. And if we get a quotient, because this fraction is top heavy, we can split it in 2. So we can say 2x squared over x, take away 1 on x. So tidying that up, 2x squared on x is 2x. Take away 1x, don't forget your integral sign and your dx. Now we're going to integrate. So this is 2x squared on 2, or just x squared. And do you remember what this one is? This is ln x, isn't it? Or log base e of x plus c. Now I said earlier that there's no way through integration of figuring out what the value of the constant was, and that's true. However, if we are given a pair of coordinates for f of x, that's our original function, we can actually find out what the constant was. And you'll get a lot of questions like this. And this process is actually called resolving the constant. So here's an example. If f dashed of x, so this is the derivative, is equal to 6x squared take away 1, and f of 0 is equal to 4, find f of x. So we're going to integrate, then we are going to substitute in the point 0, 4, figure out what c is, and then write the function. Let's start by integrating. So f of x will be the integral of 6x squared take away 1 dx. Okay, what's this? 6x cubed on 3 take away x plus c. Now we're going to substitute the point 0, 4. So 4 is equal to 0, take away 0 plus c. C is equal to 4. Therefore, f of x is equal to 2x cubed, take away x plus 4. And when we resolve the constant, what happens is, instead of having a family of curves that satisfy that derivative, we just have a single curve. So you can see that this curve goes through that point 0, 4, whereas all of these, this is the only one that does. So here's a family of solutions and a single solution where we have resolved the constant. Okay, that's it for this lesson. Next lesson, we're going to look at the reverse chain rule.